Alright, so today we are going to be doing 3.3, which is quadratic formula and the discriminant. This right here is quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. With the quadratic formula, we have something called the discriminant. The discriminant is the portion of the quadratic formula that falls underneath the square root. We can use the discriminant to help us determine the type of solutions we have, and also the number of solutions. So there's really only 3 scenarios that can occur. You either have 0 solutions, which would be no real solutions, possibly 2 imaginary. You could also have 2 real solutions or 1 real solution. Okay, nothing more than 2 and nothing less than 0. Alright, so now I'm going to show you how the quadratic formula actually came about, why it works. Okay? So the quadratic formula works because we take the standard form of a quadratic, ax squared plus bx plus c, and we actually rearrange it in such a way that gets you the quadratic formula. Now to do this, we have to solve for x. But in order to solve for x here, just like when we did notes on Thursday, we have to complete the square. So you're basically going to be completing the square just like we always do, but instead of with numbers, we're going to be using letters like a, b, and c. Okay, so let's follow through with the steps. I'm going to go ahead and go through all of them with you. Okay, so I know things kind of can get confusing when you're dealing with letters instead of numbers, so just bear with me. So step 1, just like when we complete the square at all times, we have to get the c out of the way, right? We have to get the c term out of the way, so we're going to isolate it. We're going to subtract it on both sides. And that's going to leave me with ax squared plus bx equals negative c. And remember, I always leave space for that new term that I'm going to add in, that new c term that's going to come about. So step 2 is we're going to have to divide everything by that a because we need to get rid of it. So instead of factoring out, we're going to divide everything by a. So I'm going to divide here, here, and here by a. And that gives me x squared plus b over ax equals negative c over a. So is everybody good with how I got that? Alright, so the next step to completing the square is we have to come up with that new c term. So normally we take half of this term and then we do what with it? Square it. So we're going to do the same thing here. To take half of b over a, the easiest way to do that is to simply multiply b over a by 1/2, right? And that will give us b over 2a, and then we put that to the second power, which gives us b squared over 4a squared. That's half of it and then squared. And what I add to one side, I have to add to the other side. Good. So we get here. Okay. Now, once we get to this point, I'm kind of doing this like one step ahead on each one. I don't know why I did that. But anyways, now we're going to have to try to factor this. Okay? So we learned last week that when we want to factor something like this, the easiest way to do it, instead of figuring out what two numbers multiply to give you b squared over 4a squared, what do we do? What's the trick? What do we know that these are always going to factor into? Whatever half of that is, which is just b over 2a. And then we know that if we have two identical binomials, we can rewrite it as squared. Like that. And then I'm going to rearrange these terms over here. Okay, you're going to see why in a second. This is going to become b squared over 4a squared minus c over a. So I just rearranged those terms. So is everybody with me on how I got from here to here? Okay. Next step is to find a common denominator for my terms on the right so that I can combine them. So what would be the common denominator for these two? Well, they have the a in common, but we need it to get to be 4a squared, right? See how this one's 4a squared? How can we make this one over here 4a squared? I can multiply top and bottom by
4a reciprocal.
Not the yeah, 4a. So if I multiply the top and bottom of this fraction by 4a, that's going to make it have the same denominator as the other one, right? So this side stays the same. And this side becomes b squared over 4a squared minus 4ac all over 4a squared. Okay, I just multiply the top and bottom of that second fraction by 4a. So do you see how now they have the same denominator? So once something has the same denominator, I can rewrite it as over the same one big denominator, right? Like this, b squared minus 4ac all over 4a squared. Now the next step is when we want to solve for a, or our whole goal is to solve for x, right? So in order to get rid of the, or to solve for the x, we need to get rid of the squared. So how can we reverse a square in math? So we square root both sides. When I square root this side, I have to put in a plus or minus. So this is going to become x plus b over 2a is equal to plus or minus the square root of the numerator, which doesn't simplify, all over, does this denominator simplify? Can you take the square root of 4a squared?
2a.
Or just 2a, right? Yeah. So we get here. And now my next step is I have to get x by itself, so I can simply subtract on both sides, right? That's going to give me x equals negative b over 2a plus or minus b squared minus 4ac all over 2a. I just subtracted b over 2a to the other side. Now, what do you notice about the two denominators of these two fractions? So I can write them as one big fraction, right? And does this look familiar now? So you just created the quadratic formula. Okay. Now, before we talk about anything else, I just want to make a few mentions. This formula should look familiar to you. Does anyone remember what this formula is right there?
I always think to get it from one thing to the other.
Axis of symmetry. This part represents the axis of symmetry. So if we think about how the graph looks, I'll show you on that little coordinate plane. Let's think about a quadratic. We'll pick any random quadratic. It can be positive or negative sloping. I have this. And I have the axis of symmetry down the middle. What do you notice about the distance from the axis of symmetry to the two zeros? It's the same distance, right? So finding the x values is finding one's distance from the axis of symmetry on the x-axis. That's what that is doing. That's why the axis of symmetry is part of the formula. Okay, so this is kind of your understanding. Algebra 2, we want you to get a better understanding of what we're actually doing when we make these calculations, where the formula comes from. All right? So does anyone have any questions about that? All right. So before we get into actually doing quadratic formula, we're going to do the discriminant. Okay? The discriminant. So, okay. So on this question, or on these questions, we're going to use the discriminant. So the discriminant is like a shortcut. And we can just do this little calculation to determine what type of solutions we have. So what you're going to do is you're going to do b squared minus 4ac, and you're going to compare it to 0. If it's greater than 0, less than 0, or equal to 0, that means something different each time. Okay? So for the first one, we know that b is equal to what? 25. A is equal to 2, and c is equal to 33. Usually I go A, B, C, but I don't know why I did that. So you do b squared minus 4 times A times C. And then we want to determine if this is greater than or equal to 0, or how it compares to 0. So we're going to put a box here. So I'm going to do the math. 25 times 25 minus 4 times 2 times 33. So that comes out to be 361 when I put this in the calculator. Okay? That's this. So is 361 greater than 0, less than 0, or equal to 0? So that means we have two possibilities here. We either have two real rational roots or two real irrational roots. So two things are true right now. We can say that we at least know we have two real roots, right? We don't know if they're rational or irrational. So we would say we have two real root. So somebody in my other class asked me, is there a way to know if it's irrational or irrational? And yes, there is, if you want to take an extra step. If you take the square root of this number and it comes out to be a nice even number, that's a rational root. If you take the square root in the calculator and it's like a decimal, that means it's an irrational root. So that's to answer that question. That's how you could figure it out. Now, as for the next one, what is A going to be? 3. What's B? And C is 1. So we do B squared minus 4 times A times C. That gives me 25 minus 12, which is what? So how does 13 compare to 0? It's greater than. So we have two real roots, right? But do you see how one of them is irrational and one is rational? Because 361 is a perfect square, and 13 is not. So one is actually rational, one is irrational. Okay. Next one. What's step 1 here? Identify A, B, and C. Right. 1, negative 16, and 64. Okay. What is, I'm sorry. What is B? Negative 16 squared minus 4 times A times C. That gives me 256 minus 256, right? So what is 256 minus 256? So how does 0 compare to 0? Which means I have how many roots? 1 real root. Any questions? Okay. Next one. Can I proceed as is? I have to do what first? Move C over, because it's going to give you the wrong sign if you try to take it now. So A is 1, B is, and C is, so it's negative 4 squared minus 4AC. That gives me 16 minus 52, which is negative 36. Is that greater than, equal to, or less than 0? So what's that mean? No real roots, which means your roots must be imaginary. Alright, so now that we've done discriminant, is everybody good to move on to do quadratic formula? Okay. So I know that this is something you've learned in other classes, other math classes, but it's been a while. So I'll go through the first one in a lot of detail, and then, because in this class, I'm not sure about in Algebra 1. I haven't taught that class in a couple years from now. It's been a long time since I taught Algebra 1. But in this class, you're going to have to reduce those radicals on your own each time. You can't leave it as a decimal. You can't give me a decimal answer. They're not going to always be nice. So that's one major difference I see with the Algebra 1 solving and the Algebra 2. So step 1 is you have to make sure that your answer is in standard form. Would you say this is in standard form? And then you can identify A is what? B is, and C? Good. So that's going to be x equals negative b. So negative b means whatever b is, it's going to change signs. So if it's negative, it's going to become positive. If it's positive, it's going to become negative. So b squared minus 4 times a times c all over 2a, which is 2 times 2. So any questions about the plugging in? Now, to avoid mistakes, I highly recommend that you use the calculator here. So what you should do is put a square root symbol empty, and then type all of this into a calculator, and it will do that math for you. So I'm going to type in 25 to the second power minus 4 times 2 times 33, and that's going to give me 361. Now it's important you don't try to take the root in the calculator too, Because the calculator, if you're using one of these, is not going to give you a simplified square root. It's going to give you a decimal if that root is not perfect root. All over 4. Now, it just so happens that 361 is actually a perfect square root. Does anyone know what it's the perfect square root of? Yes. 19. So, that means I have x equals negative 25 plus or minus 19 over 4. So, I can actually solve this as my two separate solutions because they're both going to be rational real, right? Negative 25 plus 19 over 4 and negative 25 minus 19 over 4. So this up here gives me something. I think 6. Yeah. So negative 6 over 4 and negative 44 over 4. So this one up here reduces to negative 3 halves. And this one becomes what? Negative 11. So here's how you write your solution to get credit. Negative 11, comma, negative 3 over 2. Now, a few questions that people ask me that I'll just kind of address here in case they apply to you. Yes, the way you write your answer will matter in this class. If you're on Desmos, you can write it with the little plus sign. You can't leave your answer as x equals. Okay, that means that's the equation of a vertical line. And you have to fully simplify your fractions. Decimals are okay if they are not repeating or irrational. All right, next one. And yes, you have to use squiggly brackets, not curved brackets. That just looks like a coordinate, and that's something totally different. All right, so what is A here? B is, and C is? Good. So that's x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That gives me x equals 16 plus or minus the square root of 0 over 2. So that's x equals 16 plus or minus 0 over 2. If I told you you could take your grade in my class and you can choose to either add or subtract 0, would you care which one I did? Because it doesn't do anything. So are there going to be two separate answers to this one? They both yield what value? No. 8. You guys understand why it's 8? Okay. Next one. Step 1, identify A, B, and C. Step 2, plug into the formula. Negative b plus or minus the square root of b squared minus 4a and c all over 2a. That gives me x equals negative 5 plus or minus the square root of 13 over 6, right? So you can't simplify that anymore, but you could rewrite the two answers as x equals negative 5 plus radical 13 over 6, and also what? Negative 5 minus the square root of 13 over 6. So to write your solutions, you would write it like this. Those two separate solutions.
Wait, so when can you put like only one, like x equals?
Oh, plus or minus?
Yeah.
That would be acceptable here too. I just wanted to give you a variety.
Okay.
But yeah, that would be fine. Just because if it's a multiple choice, you never know which way they're going to write it. So just want you to be familiar with everything.
So you can just put like plus or minus next time.
Yep. The only thing is, if you have a question like this one, see how this one you can't leave as plus or minus because this simplifies down to a real number. Can't leave. If you were to have left it like this one right here, that would be, I would take off points. But on this one, it'd be okay. You see the difference between those two scenarios? Okay. So the next one over here Can I go ahead and solve it right away?
No.
I have to do what?
The C.
Move the C over.
Okay, so now I want you guys to go ahead and try it on your own and then check your work with me, okay? When you're ready, it's up. Anybody get the answer? Really?
I got it.
I know
Guess
algebra
it.
plus, so
Yeah, we're all the
What?
top students
No,
in
no.
yeah, it is algebra plus.
What?
You guys are a
I got it.
package deal. You got it?
Negative 300
Negative 300.
So